So in section 10.3, we learned how to multiply two vectors together to get the dot product. That was called the scalar product because the result was a number, just a scalar. Section 10.4 is on the cross product. It's a second way to multiply two vectors together, and it's sometimes called the vector product because the result is going to be another vector. And just like with the dot product, the cross product gives us lots of meaningful information about the two vectors we're crossing. So I have the formula here for the cross product of A and B, and you can see it's a vector. It's got lots of stuff going on there with a little asterisk that says, please don't bother copying this formula, because although this is the formula for the cross product, absolutely nobody on the planet uses this. Everybody calculates cross products using matrix determinants. So that's all I'm going to show you how to do in this video. It's not going to seem like it has anything to do with vectors, but it's going to be the technique we need in order to find the cross product of two vectors. So what is a matrix and what is a determinant? So a matrix is just an array of numbers. Think of it like an Excel spreadsheet. You can have as many rows and columns as you need to organize with however many data points you need. This matrix is called a 2x2 matrix because it's got 2 rows and 2 columns. All I want you to know how to do mechanically is to just find this thing we call the determinant. All right, so the determinant of a 2x2 matrix, all you're going to do is multiply the entries on the down angle, A times D, and then you're going to subtract multiplying the entries on the up angle. Okay, so just a quick example, super easy. Let's say we have -1, 3, 5, 2. Again, we're going to multiply on the down angle. That gives me -1 times 2 is -2. And then we subtract on the up angle. So -5 times 3 is 15. And the determinant of this matrix is -17. The meaning of that, we don't really care about the meaning of a determinant of a matrix. We care about what this can teach us about vectors, which is what we're going to eventually get to when we have Zoom class next. All right, so let's get to the determinant of a 3x3 matrix, which is really our goal in this video. All right, so here is the formula for the determinant of a 3x3 matrix, and that does not look a whole lot better than the mess that I had on the cross product formula on the first slide, but I assure you it's a lot easier and more methodical once you get the hang of it. And we're going to do so many of these, you're going to be able to do them in your sleep by the time I'm done with you. All right, so you have 3 2x2 determinants, which we already know how to do. Those are pretty easy, and they have A coefficients out in the front. Okay, so the 3 coefficients are A1, A2, A3. And then the little matrices that are stuck by them are pretty methodical to come up with. All right, so look at the matrix with the A1. If I go over to the big matrix and I cross out the column and the row that has A1 in it, then you get that little matrix there, B2, B3, C2, C3. That's all that's left in the big matrix. And that's the little matrix that goes by it. And if you follow this pattern, that's where the little matrices come from. Okay, so in this term where I've got A2, if I go over to the big matrix and I cross out the column and the row that belong to A2, then I'm left with that B1, B3, C1, C3 that is the matrix sitting right next to the A2 number, right? And then again, the same thing for A3. Cross out the column and the row that belongs to it, and you've got B1, B2, C1, C2, and that's the matrix that you've got sitting there. And then those little bitty 2x2 matrices, we know how to find those determinants just multiplying on the down angle and on the up angle. The only thing tricky about this formula is this minus in the middle there. It's easy to forget. Okay, so the A1 and the A3 terms are positive, the A2 term is negative. All right, so let's just get some practice with this. It's straightforward, easy arithmetic calculations. We just got to remember the pattern. Okay, so here's our first 3x3 determinant. Remember, we're going to use the first row as the coefficients. So we're going to have that A1, the 1, and it's going to be times a little determinant. Our second term is always negative, so that 2 that's in the middle, I'm going to make a -2. It's going to have its own little determinant. And then our last term, it's going to be positive, but the number itself is negative. So you've got this -1 sitting out in front times its little matrix. Okay, so again, the little matrices that we're going to get there, we get by crossing out the row and the column that belong to the coefficient. Okay, so my first one, 1, I'm going to cross out the row and the column. That's going to leave me with 0, 1, 4, 2. All right, same thing. I'm going to cross out the 2's row and column. It's going to leave me with 3, 1, -5, 2. And then the last one, that -1 on the end, I'm going to cross out its row and its column. That leaves me with 3, 0, -5, 4. All right. And then all we have to do are the little 2 by 2 determinants. So remember that we multiply on the down angle and then we subtract on the up angle. And we're going to do that for all 3 of these little matrices to find their determinants. All right, so I've got a 1 out front, and then I'm going to multiply on the down angle, 0 times 2, subtract, multiply on the up angle, 4 times 1 gives me 4. Middle term, I've got -2, multiply on the down angle, and I've got 3 times 2 is 6, minus, multiply on the up angle, and that is -5 times 1. So I've got minus a -5. Then there's a -1 for the last little matrix. I'm going to multiply in the green direction. 3 times 4 is 12. Minus, multiply in the red direction. -5 times 0 is 0. And the rest is just arithmetic. So 1 times -4. See, -2 times, actually, let's write that out. 1 times -4 minus 2 times 11 minus 1 times 12. -4 minus 22 minus 12. That's a lot of negatives. So 20, 30, 4, 6, 8. -38. Let's hope my mental arithmetic is doing okay. All right, so let's try another one. All right, so here's a great place to stop and pause the video. See if you've got the hang of this and can do one on your own. See if you get the same answer as I do. Okay, so again, we're going to start off with coefficients. 2 times its little matrix, negative in the middle, always negative on that term, but that number itself is negative, so it's going to be minus a -3, or you can just make it a +3. And then the last one, plus, again, a -2. All right, and then see what little matrices you get. Okay, so I go from the 2, cross out its row and column, 1, 5, 4, -1. Middle term, cross out the -3's column and row, 0, 5, 4, -1. And then my last term, crossing out the column and row for -2, and I get 0, 1, 4, 4. All right. And again, for our little 2 by 2 determinants, we're just going to multiply in the green direction and subtract multiplying in the red direction. All right, arithmetic, 2 times. Multiplying in the green direction, I get -1. And then minus 4 times 5 is 20. Middle term becomes a +3. 0 times -1 in the green direction is 0. Subtract, 4 times 5 is 20. And then the last term is -2. Multiply in the green direction and get 0. 0 times 4 is 0. Minus, multiply in the red direction, and I get +4. And then arithmetic, 2 times -21 plus 3 times -20 minus 2 times -4. And I get -42 minus 60 plus 8. So let's see, that's a lot of negative. -102 plus 8, -94. No, -94. Okay. All right. So again, hope that my mental arithmetic is correct. Okay, so that's finding a determinant of a 3 by 3 matrix. Again, does not seem to have anything to do with vectors, but I promise it will when we meet together in class next time.